Hi, I'm Sooyoung from Atri. In this video, I'll be talking about the system for sound event localization and detection. SELD is a task that recognizes the sound event and its direction simultaneously. The SELD system uses two types of inputs. One is directional microphone recording from a tetrahedral array. The other is first order ambisonic format. The SELD system requires active sound event, onset offset for the sound event, and its spatial location as system output. Here is distribution of model submitted to the DCASE challenge task 3 so far. The CRNN model has been mainly used for DCASE challenge. In this year, a hybrid network using CNN and attention is gradually being used. We proposed the first pure transformer model for this task. The transformer we used was first introduced in a paper called Attention is All You Need in 2017. In the field of NLP, the model using the transformer showed excellent performance and began to be applied to other fields. Recently, pure transformer systems have shown excellent performance in the computer vision. So transformers are now being applied in various fields. The keyword transformer and audio spectrogram transformer are the first model to use pure transformer in the audio classification. In vision transformer, VIT first split the image into 16 by 16 patches. Then the patch embedding extracted through linear projection is used as a layer input. Single classification token, which is an extra learnable embedding, is appended to the patch embedding sequence for single classification. Each patch embedding does not have any special information in the original image, so the learnable positioner embeddings are added to the patch embedding and use it as an input for the transformer layer. Only encoder part is used in transformer to perform classification in VIT. In vision transformer, the transformer encoder is fine-tuned as follows. Audio spectrogram transformer, AST, also has the same architecture. Split the single channel feature image into small patches. Extract the patch embedding through linear projection. After that, the classification token and the positional embedding are added to patch embeddings. This is used as the input of the transformer encoder. AST obtained performance improvement by using transfer learning from the image in the pre-trained model. Our proposed model, main-to-many audio spectrogram transformer, has two major differences from AST. The first is to use multi-channel feature images as an input. The second is that multiple classification tokens are used for classification. Multi-channel feature images are required to obtain spatial location information for SELD. We use logomeric energy extracted from microphone array for sound event detection network. We use logomeric energy and intensity vector from FOA recordings for direction of arrival estimation network. The challenge evaluation is performed at a temporal resolution of 100 milliseconds. The neural network for SELD should output a series of output rather than a single output. Therefore, we design a sequential output using multiple classification tokens. You can freely set the length of this token sequence. So the length of classification token sequence determines the output resolution. This is the experiment result for the development data set. All results are based on Logarman energy and intensity vectors as an input features. The baseline large is a model in which the filter size of the baseline model is increased to be similar to our model. The proposed pure transformer model outperforms the CRNN-based models listed in the table. Now, I'll summarize our results. We proposed the first pure transformer architecture for sound event localization and detection. The experiment result shows the potential of pure transformer model in SELD. Thanks for your attention.